Okay, so this is the problem that we didn't have time to work in class. So it's one where you have two weak acids, not two, should be at the bottom, and you're asked to find the pH of the solution. So what you want to do is think about your major species. You've got HCN, because it's a weak acid, HNO2, because it's a weak acid, and water. So if you look at their Kas, this one is 6.2 times 10 to the negative 10th. HNO2 is 4 times 10 to the negative 4th, and water is 1 times 10 to the negative 14th. Because HNO2 has the larger Ka, it's going to be the primary contributor to the pH. Okay, so we're going to actually set up our rice box for only that one. And if we calculate the pH based on that, we'll know the overall pH for the reaction. Even though HCN and H2O will contribute a little bit to the pH, it's not going to be anything that is significant number-wise, especially since we're sticking to 3 sig figs. So initially we have 5 molar HNO2 and none of that. So this is just your usual icebox that we've been doing. And we're going to use the method of successive approximation here and say 5 minus x is approximately still going to be 5. So that's x and x. So if we plug it in, 4 times 10 to the negative 4th equals x squared over 5. And then so if you multiply 5 times this, and then take the square root, for x, you should get 4.47 times 10 to the negative 2. And then, so that would be concentration. So then to do your pH, since x is equal to the concentration of H at equilibrium, we're going to do the negative log of 4.47 times 10 to the negative 2. And so when you do that for the pH, you should get 1.35. So that's the first part. It also says to calculate the concentration of the cyanide ion. So I'm going to erase this. And for the cyanide ion, what I can do is I'm going to write out the dissociation equation. So the HCN forms H positive and Cn negative. And I don't even have to do an icebox. So if I set up the Ka is 6.2 times 10 to the negative 10th equals, and we're going to put the hydrogen ion concentration on top. But that's going to be the same thing that we calculated back in the first part. Okay, so whatever our x came out to be, which was, let's see, 4.47 times 10 to the negative 2. So I'm going to put that on top. Okay, I don't know the cyanide ion concentration, so I'm just going to leave that. On the bottom would be HCN, but remember if we were doing the method of successive approximation, we would say it's about the same as 1, especially since it has such a small Ka. So I'm just going to put that as 1. So when I solve, I get that my concentration of Cn is 1.48 times 10 to the negative 8th molar. Okay, so what you need to keep in mind when you have a mixture of acids is it doesn't matter which one that the H's came from, as long as you use the one with the bigger Ka. You can use that same value for the concentration of H in any of your future concentrations, because any other thing that makes hydrogen ions is not going to be making enough to change in a significant mathematical way. Okay, so pick the one with the bigger Ka, find your concentration of hydrogen, and use that from there out.